Okay, so the problem that I'm going to be solving for this video is chapter 22, problem 2, but on the homework it's listed as number 1. So basically what we're given for this problem is the diagram of an electric field. We have 2 points on that diagram, point A and point B, and we are told that the lines on the left-hand side of the diagram are spaced twice as far apart as those on the right-hand side of the diagram. Alright, so to start solving this, we're going to take a look at what part A is asking us to do, and it's telling us that if the magnitude of the electric field at point A is equal to 48 newtons per coulomb, then we need to find the magnitude of the force on a proton put at that point. So for starters, we need to figure out what the charge on a proton is, which is positive 1.60 times 10 to the negative 19th coulombs. And then we're just going to be using the equation E is equal to F divided by Q, rearrange it a little bit so that we can solve for the force. So force is going to be equal to the electric field times the charge. And these are all point specific, but in this case, since we're, talking about the same point, talking about a test charge, we already know all the information, we can figure it out. So, to solve for the magnitude of force at point A, we are just going to plug in what we know. We have 48 newtons per coulomb times 1.6 times 10 to the negative 19th coulombs. And we can see that our units cancel, so we know we're doing it right. And the magnitude of the force on a test charge put at point A is going to be 7.68 times 10 to the negative 18th newtons. And since Wiley doesn't like that, I'm going to have to throw in a whole bunch of zeros and round it to 7.7 times 10 to the negative 18th. Alright, so now on to part B of this question, which basically wants us to continue operating under the assumption that the electric field at point A is equal to 48 newtons per coulomb. And it wants us to find the magnitude of the electric field at point B. So, we recall that the lines on the diagram at point B are spaced twice as far apart as they are at point A. And knowing what we know about how magnitude and spacing of arrows lines up, we know that 2 times the magnitude of B is going to equal A, because the closer the lines are together, the more intense the electric field is. The further apart the lines are, the less intense the electric field is. So since we know the exact amount of spacing that those lines have, we can kind of determine the relative intensity of the 2 sides of the diagram. And since we know part of that, we can just plug in what we know. Should put a little e here because that would make more sense. And then we're going to divide both sides by 2. So we're left with the magnitude of the electric force at point B on the diagram being 24 newtons per coulomb. And that is going to be our final answer.